Welcome to Zeiss Inspect Airfoil. In this video, I want to show you how you can apply a series of inspections you created for one profile section to other profile sections, and that with a single click. All you need is a user-defined inspection principle, or short, UDIP. If you want to try Zeiss Inspect Airfoil, take a look at the description below. There, you'll find links to download the software, request a free trial, and download training data. UDIPs are incredibly helpful for repetitive tasks. They contain a related set of parametric construction and inspection elements for reuse. Sounds complicated, but here's what that means for our project. We created a number of elements and inspections based on the profile section: the stacking point, the camber line, the leading and trailing edge points, the maximum profile thickness, the profile edge thickness for the trailing edge, the profile thickness distribution, and the axial chord, as well as the profile form and position inspection. Like I said, all these are based on the profile section. Now for the part IGT3D, which contains the optical 3D data, the profile section itself was created in the inspection plane, plane AA. In other words, the inspection plane AA is the parent element of the profile section. For the second part in this project, IGT-CMM, the parent element would be HA section, so the section itself. UDIPs save the type of parent element, in this case plane, and the information on how the dependent elements are constructed and inspected so that you can apply them to other elements of the same type, thus reducing a series of inspections to a single click. And here's how it works. First, we need to create a UDIP. If you look at the main toolbar, you'll see that Define User-Defined Inspection Principle is the next step in the workflow support. I'll show the UDIP creation based on the part IGT3D. Now the first thing you need to do is select the parent element. In our case, that's plane AA. As soon as you do that, the expert parameters open. But let's start at the top. Enter a name. Then you have two options: tag all elements and define associated tags automatically. When you activate tag all elements, the software automatically puts all the nominal, actual, and inspection elements that depend on the parent element, in this case plane AA, in one tag. Now, as you might remember, we manually created tags containing a subset of elements for the profile inspections and the profile form and position inspection. With Define Associated Tags automatically, the software automatically creates all these tags for every other parent element, so every other plane. In this case, we want both. Now in the expert parameters, you can create a new inspection principle or use Overwrite Inspection Principle if you want to update an existing UDIP. Underneath, you can define additional parent elements. Sometimes elements that are required for the execution of the UDIP don't depend on the parent element, in this example, plane AA. When that's the case, you need to define additional parent elements. If you look at the dialog underneath, you'll see a warning sign here. That means that this element requires an additional parent element. That's the stacking point, which depends on the plane AA and on the stacking axis. And when you hover over the warning sign, the software tells you which additional element is required, the component coordinate system. So all you need to do is select it in this drop-down list. A little side note here. Make sure that the additional parent element has a descriptive name, such as component coordinate system. The software creates a function dialog for the UDIP, and the name of the additional parent element will be used to name the respective field in the dialog. You'll see what I mean in a second. The additional parent elements vary depending on your inspections. For the part IGT-CMM, you require 2 additional parent elements, for example. But in any case, the software helps you find them. Adding each one also provides the opportunity to check if the suggested parent elements make sense. Enter a description here, and you can load an image or use the current 3D view. Then click OK to create the UDIP. Now for the exciting part, using the UDIP. But first, let's take a quick look at the tags here. Because we used the option Tag All Elements, the software created a new tag containing all the elements that depend on inspection plane AA. And the software renamed all the existing tags, adding the name of the UDIP and the parent element as a prefix. This will be handy for reporting later. Now let's inspect the additional planes in this project using the UDIP. Open iInspect. As you can see up here, iInspect now features another menu called User Defined Inspection Principle. To activate it, you need to select a suitable element. Remember, the functions available in iInspect depend on the elements you select in the 3D view or the Explorer. In this case, we need to select a plane. To make things even easier, you can select all the inspection planes with Control and the left mouse button. Then click User Defined Inspection Principle in iInspect. When you hover over the UDIP, you get a tooltip with the image and description we entered when defining the UDIP. This is really handy if you have multiple UDIPs in your project. In this case, we only have one UDIP, so let's select it. Now you can see why it's important to enter a descriptive name for the additional parent element so that people know what to select. Select the component coordinate system. Click OK, and you're done. On a side note, if you have multiple UDIPs in your project, you can get an overview under Edit, Manage Templates. In the drop-down list, select User Defined Inspection Principles. Here, you can see all the UDIPs in your project and their parent elements. You can also view the description and image by hovering over UDIP. Let's set the cat to invisible so you can see better. Here you see the profile form and position inspections. But thanks to the automatically created tags, you can display all the elements related to plane BB, for example, or the profile inspections for plane DD. UDIPs are great, aren't they? So simple to create and use, but with a big impact on efficiency. And the best thing is, you can share UDIPs with your coworkers using apps. For more information on how to do that, have a look at the tech guide. That's it for UDIPs. A short reminder, if you're working with optical 3D data, the base element for your user-defined inspection principle will be a plane. If you're inspecting CMM data, the base element will be the radius-corrected section. If you're looking for more comprehensive training, take a look at the Inspect Airfoil Optical 3D Data Basic e-learning or Inspect Airfoil CMM Data Basic e-learning. You'll find the link in the description below.